This is March 2025, paper 52. We just go over the suggested marks allocation. After 2022, the marks allocation is not that much rigid now. But for our convenience, we follow this that defining the problem, I mean defining the variables, it's 2 marks. Then methods of data collection is again 4 marks. And method of analysis is 3 marks. Then additional detail including safety consideration, we have to allocate 6 marks. Now we are starting this paper and the question says figure 1.1 shows two identical cylindrical metal conductors P and Q, each of length L and cross-sectional area capital A. Look, this is the case. Now, this is the case here that we have two cylindrical metal conductors. These are two long rods. Each rod has a length capital L. The separation from a surface, one rod has a separation Q and second rod has a separation P. The conductors are placed parallel to each other. The perpendicular distance from the midpoint of P to Q and X is P. The perpendicular distance from the midpoint of Q to midpoint X is small q. This is important for paper 5, design question. Everyone should has to read the question at least 2 times. This will be ideal to read the question 2 times. The two conductors are electrically connected in parallel. This parallel combination is connected in series to a power supply and a resistor. The potential difference V between the ends of P is the same as the potential difference between the ends of Q. Now, the conductors are placed parallel to each other. The perpendicular distance from the midpoint of P to point X is P. The perpendicular distance from the midpoint of Q to point X is Q. We can see the diagram back here. Look, the two conductors are parallel. Separation from a point X. One cylinder, which is Q, has a separation small q. The cylinder P has a separation small p. They are perpendicular separation. Now, it is advisable that you should read the question again once yourself and absorb the detail, because if we read something wrong and apply it, then it will be a major problem. So 15-mark question, you can score very high if you read it correctly. Obviously, different people will have slightly different approaches, instruments and approach. That won't matter. But a wrong justification will be a big problem. So now read the question. This part is important. They always give a lot of detail.
Okay, done.
The magnetic flux density at X due to the currents in the conductor is B. What magnetism is doing here? This concept is called electromagnetism. This concept is called electromagnetism. Now, what is electromagnetism? Electromagnetism says that when current is passing through a conductor, it produces a magnetic field. This is called electromagnetism. Okay. It is suggested that B is related to P by the relationship. This is the formula given here, where Y and Z are constant. Now they have given letters B, A, V, L, P. This is the common pattern of this question 1, that they give you a big equation. They give you a big equation. They want you to find out the variables, unknown constants, maybe. Now, this page again is important. The theory is very important. It means that these are going to be two current carrying conductors and they are going to produce magnetic field. Magnetic field is Tesla, which is represented by the letter B. Plan. Now, these are the two crucial lines. Underline, I have them. I have underlined them. Plan a laboratory experiment to test the relationship between B and P. What B and P has to do here? B and P is actually B. B stands for magnetic field strength.
And P is the perpendicular distance from the midpoint of P to point X.
Draw a diagram showing the arrangement of your equipment. Explain how the results could be used to determine values for capital values for Y and Z. Values for capital Y and capital Z. So now we have a quick review what we have discussed. Two conductors parallel connected, going to be connected with a power source in series, and then they are going to get current. The current will create electromagnetic effect. Magnetic flux density at X due to the currents in the conductor is B. Draw a diagram showing the arrangement of your equipment. Explain how the results could be used to determine values for capital Y and Z in your plan. Achha, these bullets are always there, so you should remember them. Procedure to be followed, measurements to be taken, control of variables, analysis of the data, any safety precautions to be taken. Now look at this idea. Variables, defining the problem. These are the 2 marks. No need to copy the second line. Give the first title heading in the printed form. If you have a printed form of paper, then you have to be on the second page. There is a space for diagram. Leave that space right now. Below the space, start from the lined area, give the heading variables.
Yeah, done.
Look at this. P is the independent variable and P is the dependent variable. Give the heading variable. Achha, how we decide who is independent, who is dependent? The most crucial part of the question. Whatever you can change is the independent variable. Whatever changes according to your variable is the dependent variable. What is P? If I go back and I see the P, look at this is the P. P is the separation of the upper rod from the point X. So I
Yeah.
can easily locate the value of P. So I can say I can change the value of P. P is the independent variable. B is the dependent variable. Now what about V? Potential difference between the ends of each conductor constant. So my plan would be to keep the voltage constant and alter the value of P. And let's see how B will change. So this you have to copy.
Okay. Done.
Right. Now give us side heading procedure. Side heading procedure method of data collection. In our older justification, we say there are 4 marks after 2022. The marks are open now for the checker, but we follow a convention. A well labeled workable apparatus diagram is needed. This is a very good hint to remember. You need to draw here a very well organized workable apparatus diagram is needed. Okay. Now, how you give the heading procedure.
Yeah, done.
Give the heading procedure, and we are now starting our thinking process. The most important part of this question is the thinking process. How you manage the thinking process. Call upon the equation. Now, this is the equation. This is my thinking process. This is like a rough working where you should do the rough working on the first page of the question. Use pencil so he knows that you're not supposed to check it, or on the last page if you have a space there, do it somewhere as a rough working. This formula will tell me what I have to measure, what instruments I have to get. So B, you have to copy this as a rough working.
Okay.
Every quantity should be highlighted.
Yeah, done.
B is magnetic field strength, Y is constant, and Z is also a constant. A is area, V is voltage, and P and Q are length. So why I'm highlighting it? Actually, after writing this, I can do my mental work because I have to suggest instruments, measuring instruments to the examiner. Now, let me call the first thing. No need to copy this, just recall. This instrument is called Hall probe. Hall probe once calibrated, Hall probe once calibrated can be used to determine once a Hall probe once calibrated can be used to determine the magnetic field strength. It can be used to measure the magnetic field strength, but it has to be calibrated. Hall probe needs calibration. You can't use it directly like other instrument, like a protractor, take it out and use. But this instrument needs to be.
It's connected to a. Do you have to connect it to a like a CRO first?
You have to first calibration. You have to first connect it or place it in a known magnetic field. You have to first place it in a known magnetic field and measure the voltage there. Then you have to put it in the target magnetic field and determine the voltage there and apply the ratio to get the new magnetic field. So Hall probe needs to be calibrated. There are two instruments in our course, CRO and Hall probe, which needs calibration before use. Now, this is the Hall probe. It has there is a control box on one side. Magnetic field is taken like this. Hall probe is one of the most sensitive instrument for magnetic field strength in our course. Other options like search coil, current balance are there, but Hall probe is very handy, very sensitive. The problem for Hall probe always is temperature. Like here, you are having two big conductors, so you have to be careful that temperature will be a big problem for Hall probe, because Hall probe can be in trouble if temperature comes in, heat comes in. How to measure L and P and Q? For example, I can use a ruler, caliper. This is a digital caliper. I'm using it for cross-sectional area. How I'm going to use it for cross-sectional area? I will be using for cross-sectional area by the formula area is equal to pi d square upon 4. What is d? D is diameter. Diameter will be measured from, we will measure the diameter from the caliper. We will use caliper. We will use caliper to measure. We will use caliper to measure the diameter. We will take multiple readings across the conductor. We will take multiple readings across the conductor wire, and we will measure the diameter readings. Then we will take an average. After we take an average, we can calculate the area. So this is how area can be determined. Length like P, Q, L, they all can be measured. Now, voltage or PD, this is our voltmeter. We can use voltmeter to measure voltage, or this is a voltmeter. Voltmeter can be used to measure voltage or PD. Now, we go for a diagram. For this part of the question, you should try to come on the area which is dedicated for diagram. It's normally a bigger space, but you have to be careful that sometimes you may have to draw two diagrams. So you have to make up your mind. Diagram should be drawn with pencil, but it should be a dark pencil, HB, or any dark impact, because they scan the paper. So the diagram should be dark, but not thick, not very dark, means that you're not supposed to make it thick. Now let us develop the diagram. Let us develop the diagram. This is the conducting area, and these are the two conductors, voltmeter and P and Q are shown here. P and Q are shown here, and the two conductors are parallel to each other. The two conductors are parallel to each other. This is a switch, battery, a load resistor, and you have to copy this diagram. You have to copy this diagram neatly. Now, we have shown Hall probe at the position X. The load resistor is here. The load resistor is here to control the current. Rheostat variable resistor will be also controlling the circuit. It's a double protection because these are two long conductors, so the resistance would be very low and current can be overshoot. So in order to control the amount of current, in order to control the amount of current, we use two parallel conductors. These are the two parallel conductors, and there is a load resistor, rheostat, and this is the circuit diagram. Now, we have to start the process. The diagram we have made, and the two conductors are there. The process actually involves, you have to explain whatever you can regarding the procedure, and remember what are the variables. The two variables are P, Q, and like that. You can show meter rule. You can show meter rule with position P, with position Q. Why you can show meter rule there? Because actually meter rule will be used to measure the meter rule will be used to measure the length. So I can draw a meter rule here. This is a meter rule, a rough diagram. I can draw a meter rule here, and my plan is to measure the position P. Meter rule should be as close to the pipe as shown. This is the meter rule. Now you can draw meter rule neatly. Acha, this is always to remember that nothing can be shown without a proper support. Here I can draw a stand in 3D in the back side. A meter rule can be shown here, and the meter rule will be on a stand. Labeling is really important. Meter rule, this is the meter rule, and when you switch on the circuit, the electrical circuit will create magnetism. Okay. Now, this is the whole circuit diagram. Draw the meter rule for to measure P and Q.
Okay.
Now, if you have space, you can draw this diagram also, but not necessary. But otherwise, you can explain it in your wording also. Normal wording is fine, that you can explain that how you're supposed to measure the cross sectional area. Now, this is the pipe, the cylinder. This is the cross sectional area. Now, this area is determined pi d square upon 4. D is equal to diameter. We already have discussed this plan. So if you want to draw, you can. Otherwise, we can just write the formula in our procedure. So now let's start. Procedure. Arrange the apparatus as shown. Arrange the apparatus as shown. You should write it in as a dictation.
Yeah.
Make sure that two rods are parallel. Make sure the two rods are parallel. By using set square or plumb line. Make sure the two rods are parallel. Use set square or plumb line. Variable resistor should be connected in series. Variable resistor should be connected in series with resistance at maximum. Variable resistor should be connected in series with resistance to its maximum. the load resistor the load resistor is the load resistor is to manage the amount of current. Load resistor is to manage the amount of current it prevents a short circuit. It prevents a short circuit meter rule should be perfectly vertical. Meter rule should be perfectly vertical. Confirm this by using set square. Confirm this by using set square. Hall probe must be perpendicular to the magnetic field. Hall probe must be perpendicular to the magnetic field. Hall probe must be calibrated before use. How we can calibrate Hall probe? Hall probe Hall probe can be calibrated by using Hall probe can be calibrated by using a known voltage and known magnetic field circuit. Switch on the circuit. Switch on the circuit. Allow the current to be stable. Allow the current to become stable. Take voltmeter and ammeter. Take voltmeter reading. Sorry. Take voltmeter reading.
Sorry, sir, can you repeat from the whole probe? I think your voice cut out a bit.
Acha, sorry.
Can you repeat from the whole probe, please?
Switch off the circuit. Allow the circuit to cool. Switch off the circuit. Allow the circuit to cool. Now change we should recall what were our variables. Our variables were, look at the variable part here. Our variable was small p, the separation. Okay. Let's continue the working, the procedure. Now change the separation q. Now change the separation q. Repeat the trial. Repeat the trial. Record the voltmeter reading. Repeat the trial. Record the voltmeter reading.
Sir.
For every trial, record. For every trial, record the whole voltage. For every trial, record the whole voltage. Monitor voltage and P. Monitor voltage and P. As they have to be constant. They have to be constant. In the end, switch off the circuit. In the end, switch off the circuit. Disconnect the rods. In the end, switch off the circuit. Disconnect the rods. This is a safety purpose. Now we have done the whole procedure. Now look at this. This is the area function. So now you have to mention, now you have to write in the same paragraph. You no need to make bulleting here. Paragraphing is fine for procedure. Otherwise, you can do the bulleting. Now you have to continue the paragraph. Use a vernier caliper to measure the diameter. Measure the diameter. Use a vernier caliper to measure the diameter. Measure the diameter from different positions and take an average. So what's the concept? That we should measure the diameter on different positions, take multiple readings and take an average. So you have to copy this formula. This part of the diagram can be shown in the diagram section also. Now give a side heading, control of variable. This is a formal heading, control of variable. What to change, what to measure. Vary P. Now smile the plan. We will change the length P. We will change the length P and we will measure B. So copy this. Have you copied it?
Yeah.
Okay. Now look at this analysis, method of analysis. It's a 3 mark portion, and make a habit of making a partition. Partition will save the lines because this is a mathematical workout. So instead of writing separately in lines, make a partition. So 3 lines, 3 lines will become 6 lines because it's like a mathematical derivation. So give the heading, side heading, analysis, which is y is equal to mx plus c. Always remember to identify who is going to be on y axis and who is going to be on x axis. In my case, the magnetic field strength is going to be on y axis, and the value of p will be on x axis.
Yeah.
Now look at the derivation. This is a mathematical generalization, but this time it's a simple work. The equation is already well organized. Just write 1 upon p separately, then compare it with y is equal to mx plus c. You need to draw a graph of b against 1 upon p. Then there comes the famous sentence: the relationship is valid if the graph is a straight line not passing through origin. So you have to copy this. Let me know once you have copied it.
Done.
Right. Now you have to copy this also, gradient, and we need to find y. They asked us to find y and x. So copy this also. Have you
Done.
copied it? Now copy
Yeah.
this also for z.
Done.
Now let us talk about precautions. Quickly wind up. Precautions are normally two types, and this will cover automatically the smart points. Smart points are not supposed to be given separately. These are the marking scheme points. You can view them later. And this is a good habit to first solve the question yourself and then see the marking scheme. But do it yourself completely. Now this is a high voltage, high current circuit. So give the heading precautions.
Yeah, done.
Number one, use electrical insulation gloves. Use electrical insulation gloves.
Yeah,
Second, the clips should be properly tight. These are the clips. The crocodile clips may be used, but the clips should be properly tight. Clips should be tight.
yeah,
Number three, hall probe distance from X should be constant. Hall probe distance Hall probe distance Hall probe distance from X should be constant.
yeah.
Okay.